Hello and welcome to Physics and Astrophysics at the University of Central Lancashire. My name is Dr. Karen Syres and I am one of the physics lecturers and I'm also Year 1 tutor for physics, so I also look after the first years when they arrive. So it's a real shame that you weren't able to come and have a look around our physics department, to see our excellent facilities and to meet other members of staff and our really enthusiastic students. But obviously we're in the situation we're in, and so instead you're having this virtual open day. So I really hope that I can give you a flavour of what we offer and the kind of opportunities that you'll have if you come to UCLan. Okay, so what courses do we offer? Well, you can study for 3 years and you can gain a BSc, a Bachelor of Science. Or you can study for an additional 4th year to get your MPhys, so that's your integrated masters. So you do make a decision on that at the start of your study, but if you do change your mind throughout the degree, you can. There is opportunities to switch. So if you decide that you do want to do the extra year, or you don't want to do the extra year, then there is the opportunity to switch. So what do we offer then? We've got physics, we've got astrophysics, we've got physics and astrophysics, and we've got mathematical physics. So you might be wondering, what is the difference between these? Well, basically there's a few differences with the core modules and the optional modules that you would take with these different courses. Obviously the astrophysics ones would have more core astrophysics that you need to learn. So you can look at these in the degree programme structure, which is available in the course handbook. And the course handbook is on our physics webpage. So just Google UCLan Physics, follow the links, and you'll find our course handbook, which will give you all the information about the modules. So all of our courses also have the option of a year abroad and also the option of a year in industry. And also they all have the option of the year 0, so the foundation year as well. So if you don't quite make the grade, you can go through foundation year. So all of the UCLan courses are accredited by the Institute of Physics, which is the UK's professional physics society. And this is really important. So if you are looking around at other universities to do physics, then always make sure that their physics degree is accredited by the IOP. Following your degree, you can actually use that to as a step towards becoming a chartered physicist with the Institute of Physics, if that's something that interests you. Okay. So, what sorts of things are you going to be learning about? Well, we have a whole range of topics that you would expect from a physics degree. So you've got electromagnetism, which is the theory of light, radio waves, X-rays, so the whole electromagnetic spectrum. And this is all underpinned by Maxwell's equations, so that's the foundation of electromagnetism. You'll be learning some computing, so you'll be applying skills of computer programming to physics problems. Electronics, so obviously this is the basic technology behind mobile phones, computers, and the whole modern world basically. And you will learn the theory behind electronics, but you'll also have a lot of really hands-on experience putting together electronic circuits. So plasma physics, so that's all about how extremely hot gas acts. Quantum physics, so everybody, obviously if you're going to do a physics degree, you of course you want to learn about quantum physics. So this is obviously getting to really small things, so you've got atoms, electrons and quarks, and then also small things, nanomaterials, so working with nanoscale physics. And of course you do some laboratory physics, so more hands-on stuff, usually using specialist equipment, carrying out experiments. And you do a project, so completing a major piece of independent work. And the project comes in the 3rd year, so it's your BSc project. And basically what happens is you choose a supervisor to work with, and you do your project in their research group alongside postgraduate students. And the students really enjoy this, so I get a lot of students saying that this has been the best part of their degree. So this is something that the students really do enjoy doing, these projects. Okay, if you're doing one of the astrophysics degrees, then obviously you're going to learn some astrophysics as well. So in addition to the physics topics, you're also going to be learning about planets. So how do they form, the likelihood of life, stars and stellar evolution. So what are the stars made of? How do they evolve? Galaxies and quasars, so we're sort of going to bigger things now. So the structure of galaxies, populations, their energy sources. And then even bigger, going to cosmology, so that's the development of the entire universe. And then also solar physics. So this is obviously about our own star, the sun. And so solar activity, the corona, how that interacts with Earth. So things like solar flares, how that can affect communications on Earth. And also computing, and so applying your computer programming to your astrophysical research. So our teaching methods and specialist labs. So we use a variety of teaching methods. So obviously lectures. Obviously we're teaching physics, so you can't get away from some of the more sort of standard forms of teaching. So lectures, seminars, like we've already mentioned, laboratory work. You also do some projects in small groups, so we do some group work, and things like tutorials. So we have a number of specialist laboratories. So we've got our nuclear laboratory with radioactive sources. We've got optics laboratory, astronomy laboratory, image processing, we've got the laser lab, and you've got your computer-based laboratory. So we've got all these specialist laboratories. And you've got a picture of a dark laboratory there, the optics lab. Okay, so with the UCLan physics degree, the first year is actually common to all of our courses, which I think is brilliant. Because what it means is that if after the first year you've suddenly discovered some passion for astrophysics that you didn't realise you had, then you can still, at the end of your first year, you can actually transfer from, say, physics to astrophysics or vice versa. So it gives you the opportunity to switch at the end of the first year if you found something that really takes your fancy. And it also just gives you a flavour as well about all the different, all the different topics. So the first year modules that you'll get are practical physics, which is laboratory physics and computing. Electromagnetic radiation and quantum theory. You'll get applied physics and linear systems. You'll get mechanics, you'll get maths module, which is functions, vectors and calculus, and then your astrophysics module, astrophysics 1. And as part of that, you get to go to Alston Laboratory to take measurements there. So if you were to stay on and do the additional fourth year, so the master's year, you actually spend all of semester 2 doing a research project. So it's a little bit similar to the BSc project, but now you would actually devote all of your time to it in the second semester. So you can really get your teeth into a research project. And again, you would be working within one of our research groups. In the first semester of the fourth year, you do some really specialist modules. You don't do all of these ones that are listed. You choose a few of these. But these are quite specialist depending on the specialisms of our lecturers. Okay, so that's what the fourth year would look like. So what kind of real world skills will you learn from a physics degree? Well, obviously we're physicists, so we solve problems. So of course you're going to get problem solving skills, and that's why employers like physicists, because we're good at solving problems. Obviously you are going to learn something about physics and astronomy, we hope. You're going to learn programming and computing skills, technical writing, design and develop a project. You're going to be working in teams, so you get some experience of teamwork. You're going to be using our specialist equipment in the labs or in your research projects. And you're going to be using advanced computer simulation modelling and, of course, experimental skills in the laboratory. So you get a whole array of skills there from doing a physics degree. And like I said, this is why employers like physicists. So this is a slide which shows us the starting salary of physicists a year after they've graduated with their physics degree. And so obviously at the bottom, going from red, orange and up to green, you're starting from sort of up to 20,000 and then 20 to 25 and then 25 to 30. So it's showing that actually only a year after graduation, the students are getting a pretty decent salary. And actually, I really want to know who is earning over £50,000 a year only a year after graduating. Yeah, I feel like I've gone into the wrong profession here. Yeah, that's very impressive a year after graduating, isn't it? So this data was taken in 2006 to 2010. And it shows that the average physicist salary is 14% higher than the average graduate salary for over all subjects. So like I say, physicists are in demand. And there's also a clear correlation between the salary and your degree classification as well. And also people who stay on and do the fourth year, the MPhys, or you do an MSc, they have higher salaries than the BSc students as well. So that's good news for if you get your physics degree, you graduate and you're looking at a decent starting salary. So physics at UCLan. Well, what makes us different? Well, we've got research-led teaching. So all of our lecturers have PhDs, so we've all got our PhDs, and we all carry out research and we publish papers. And there's something called the Research Excellence Framework, and this is every 6 years. And basically, we return all our staff to this. We submit our staff and their outputs, so their publications and the impact. And this all gets ranked. They sort of rank all the universities according to their research outputs and impact. And so we take part in this. And so the research that we do does sort of inform what modules we teach, especially in the optional modules in 3rd and 4th year. So I was talking about these specialist modules. And so that's based on the research interests of the members of staff. And also, while we're on the topic of research, a lot of people think that lecturers have the summer off to do nothing while we don't have the students around, but actually the summer is our opportunity to actually get some research done. So we definitely do not have the summer off. We do lots of research. Okay, so what else have we got to offer at UCLan? Well, we've got opportunities beyond the degree. I'm going to talk a little bit more about those in a minute. Our tutorial system, our friendly department. So I think our department is actually really friendly, and this is one of the reasons why I really enjoy working here. So I think the staff do genuinely care about the students and trying to do the best for them. And because we are quite a small department, the students do get a lot of one-on-one attention from us. And so we're quite happy for students to knock on our office door and ask us questions. And we always try to do our best for them, whether that is academic help or help with personal problems. We do always try our best for the students. And so I think it's a really nice environment to work, and it's a really nice environment for the students as well. So yeah, we're very friendly. We've got a number of unique facilities, which you could have had a look around if you actually were able to come around our department. And we're growing in numbers. So we're talking about our research. What sort of research do we do? Well, We have nanophysics, which kind of covers what I do. I'm looking at stuff on the nanoscale. So, for example, design of smart materials for the future. Graphene, so I'm sure you've all heard about graphene. It's this two-dimensional material. It's this newest form of carbon. Magnetic materials, so fundamentals of data storage. Energy generation, so this also is related to my research, so efficient renewable energy production. So I actually look at materials for solar cells and also for CO2 capture. Then we've got astrophysics, so understanding our origins. Solar physics, which is all about our sun. And laser physics, so optoelectronics and telecommunications. So nanophysics, so this is obviously looking at matter on the atomic scale, and this little animation here is an animation of a scanning tunneling microscope. So this is where you bring this tip in really close to your surface and you scan your surface. You get what's called a tunneling current. It's actually quantum tunneling. And from that, you can actually build up a really detailed map of your surface, and you can actually see atoms. So you get atomic scale resolution of your surface, which I still find pretty incredible. So this is actually work by, it's a technique that is used by Joe Smurden, one of our other lecturers. He is a surface scientist like me, so he looks at surfaces. I also look at surfaces, but I use spectroscopic techniques rather than these imaging techniques that he uses. So I actually go after particle accelerators called synchrotrons. I usually go to various ones around Europe, and I actually study not just solid surfaces but also liquid surfaces as well. And these particular liquids that I look at, called ionic liquids, they have potential applications for solar cells, CO2 capture, batteries, all sorts of things. So yeah, surface science is it's good stuff. Then also there's a picture of graphene there, which I already mentioned, two-dimensional material, and obviously that's got lots of potential applications as well. Analytical acoustics. Now, I don't claim to know much about this. So this is all about modelling and theory. So you've got the generation and propagation of sound in complicated flows and environments. And you get this local energy flow in evanescent waves and extensions of ray theory. So this has lots of applications in modelling noise in turbofan jet engines and various other things. So also we have solar physics. So this is obviously our sun. In February 2010, SDO, which stands for Solar Dynamics Observatory, was the first mission to be launched for NASA's Living with a Star program. And this is all about understanding the influence of the sun on the Earth, so by studying the solar atmosphere and its magnetic field. And in fact, UCLAN is the sole UK partner of the SDO, and it hosts the primary data archive as well. So this solar physics is a really, really strong research area within our department. The first picture of a black hole. Okay, so you may have seen in the news last year, April 2019, this was global news, that astronomers had taken the first ever picture of a black hole, and this is it. So this is at the heart of a distant galaxy, M87, in the Virgo galaxy cluster. And the size of this black hole is 40 billion kilometres across. And you can see on the picture there that our solar system is is shown in the centre as a kind of scale as to how large this black hole actually is. So obviously our solar system is very tiny in comparison. So this thing is obviously massive. And this was taken by the Event Horizon Telescope, which is a network of 8 telescopes across the world. And this is a picture of our head of school, Professor Derek Ward Thompson, and he was part of the team who took that picture. So obviously that was pretty big news. Okay, opportunities beyond the normal. So I think we've already mentioned a few of these. The tutorial system, a friendly department. We also have a university research internship scheme. So there's actually opportunities during the summer for students to actually work, again, within research groups and carry out research projects over the period of a few weeks. So they're really great opportunities, and obviously really great to put on your CV and to get experience in working in different research environments. We have international travel bursaries and opportunities, and I'm going to talk a little bit more about travel in a minute. Industrial links, so group projects within industry. Team building exercises in North Wales. So last year, as year one tutor, I went on this frontier education course with the first year students to North Wales, and we did lots of fun stuff. I fell over in a lake and got very wet, and there was lots of fun activities of canoeing and various other things. We also have the first year physics challenge, which I'm going to talk to you more about in a minute. And also social and sporting events. Okay, so I mentioned travel. Now, I don't know how, but somehow the students managed to wangle these really exciting trips to places that I've certainly never been to, so they're better travelled than I am. So this is sort of going back over the last sort of 10 years. So they've been to South Africa and Namibia, China, Hawaii, that was to see the transit of Venus, NASA. For a few years in a row, they went to CERN, so that's the particle accelerator at Geneva, and they've been to Barcelona, and obviously we've got some pictures here of some of those trips. And last year, so this is summer 2019, they went to Hawaii. So we've got this. These are generally organised by the UCLan Physics Society. So you can see this picture on the left of our undergraduate students, and they're advertising the UCLan Physics Society, and then there's various pictures of them enjoying themselves. So yeah, you've got some really great opportunities for international travel, which I'm very jealous of. Okay, so physics challenge. So the physics challenge is it is as it suggests, a challenge. So we put forward some physics challenge. This is for the first year students, and they then work in small groups to sort of build something to try and to meet this challenge. And they have a supervisor. So all of the one of the lecturers would be the supervisor for each group. So in 2014, this was before I started working here, so I wasn't around for this, but they had to propel a tin of beans over a 50-metre course with no motors and no batteries. From what I understand, there was actually some quite dangerous attempts here. I mean, you can see them holding skateboards, and I'm sure I heard rumours that there was a fire extinguisher being set off to try and propel the tin of beans. Yeah, sounds kind of dangerous. In 2015, I was involved in this one. This was where they had to design and build an electric motor from scratch. This is a picture of all our undergraduate students, the first year students at Manchester Metropolitan University, where this regional final was being held, and we finished third in that. And then in 2016, the challenge was to take a litre of freshly boiled water and convert it into mechanical energy. And so you had to raise the largest mass by the greatest distance, so it's lifting something up. And this time it was our turn to play host at UCLan. So that was in 2016. Then in 2019, so last year, we actually won it last year, which was excellent. So this is a picture of our winning team. Well, it's a mixture of the students, and then you've got Joe, who was their supervisor at the back. We've got our technician Rick, and a couple of other people. And the challenge here was to build a voltmeter to make the most accurate measurements. So our other competitors here, actually, we had quite a few competitors: Salford, Manchester, Nottingham. So and we actually won this. So yeah, the students did really well there. So we also do a staff student five-a-side football team tournament. So we actually we sort of put the staff against the students in this five-a-side tournament. So we've got various pictures here of some groups of undergraduate students, postgraduate students, staff members. The staff members are in the bottom right-hand corner there. And so yes, like I say, it's very friendly, and we like to try and have these little social and sporting events. And actually, talking about the gym, so the Sir Tom Finney Sports Centre, where these pictures have been taken, it's really close to the physics department actually, so you can save your energy for when you get there. And it's a really good gym actually. It's free to all students, and they've got some really excellent facilities. Obviously you can take part in these sorts of group sports. There's lots of various sessions, things like yoga, and you've also got a squash court, so I like going and playing squash in the squash court. So yes, it's a brilliant facility, and it's free as well, so yeah, we definitely take advantage of that. Okay, so the final slide, this is our standard offers. So the entry requirements are, if you want to do the MPhys, then you need ABB, and if you want to do the BSc, then you need BBB. If you don't quite make the grades, then there is also the foundation year alternative as well, so you do have the year 0 alternative. So okay, like I said, it's a shame that you were not able to come and visit our department, which I'm sure you would have really enjoyed. But I hope that you feel like you know our department a little bit better now. And we'd be really pleased if you came and joined us. So thank you for listening, and I hope you enjoy the rest of your virtual open day. Okay, bye.